At AV&R, our mission is to humanize robotics. We decided to create this podcast series to help you demystify the world of robotics and discover what some of the brightest minds in the field are doing. Welcome to Robotics for All Podcasts by AV&R.
In this episode, we're excited to welcome Rishabh Agarwal, who is CEO and co-founder of Peer Robotics. Having grown up as part of a manufacturing family, Rishabh left a career at Siemens and dropped out of his PhD to start his company and establish it as a trailblazer in mobile collaborative robotics. Peer Robotics is reshaping industries by offering smart, affordable robots designed to work alongside humans, leveraging no-code deployment and real-time learning capabilities to enhance operational efficiencies. Their innovation around haptics and real-time learning is fascinating. Stay with us as Rishabh and I unfold the story behind Peer Robotics' revolutionary approach to robotics and manufacturing. You won't want to miss out on this enlightening conversation that touches upon the future of work. Hope everyone enjoys the show. Here we go. Hi, Rishabh. Thank you for joining me today.
I appreciate it, Mike. Thanks a lot for having me.
Yeah, I'm excited to chat with you. Preparing for this, I did my due diligence. I looked at the Peer Robotics website. I went through some of your videos, and I got to say, it's really cool stuff you guys are doing. But there's no About Us page on your website. So let's start there. Tell me about Peer Robotics and how it was started and what you guys are all about.
Absolutely. So first of all, like Peer Robotics, we are all a group of engineers trying to make robots simple. That's kind of our philosophy: simplicity and cost effectiveness. But I'll go a little bit further. I myself come from a manufacturing family. So my family has their own manufacturing units, different units. Like my dad has a car radiator, brother runs a corrugation machine or manufacturing, and another one runs an aluminum extrusion. So complete family out of manufacturing. And growing up, I did my bachelor's in mechanical and focused on robotics, and then did my master's in robotics, worked in Siemens in Germany after that. And one thing I realized is that even though we are talking about robotics and automation so much, it's still very limited to only large enterprises. Small, medium-scale companies who are manufacturing can't really use this automation today, simply because it's too complex and they're worried about how to use it. It's not that they don't want it, it's just too complex for them, right? So that's the reason why we started working on Peer Robotics, and the entire team, Alok, Manoj, like different team members from different backgrounds in robotics and vision systems and mechanical engineering, electrical engineering, came together to make this happen. And yeah, we are trying to do our part and make robots simple enough so people on the shop floors can use it.
Yeah. So you saw the potential in the small, medium enterprises and the problem they're facing of, one, when you're a small enterprise, I'm imagining you got to do a lot yourself. So that simplicity you talked about, key element, and then cost effective. A lot of the small medium enterprises that we deal with, they want to embrace technology. They want to do a lot of cool things, but you've got a list of priorities, and you got to make sure you go after the stuff that gives you the best bang for the buck. So I can certainly see that cost effectiveness and simplicity that you guys go after as being a big deal. What size of companies would you say right now is your best customers? It's great to think about small, medium enterprises, but are they the ones investing? Did you find a good base out there?
That's a very good question. Yeah. And the reality is that when we started going out, started working with some of the companies, and to be honest, we are not there yet where we want to be in terms of our simplicity and cost effectiveness. We are going towards that. We are working towards that. But even today, majority of our business do come from large enterprises, which are automotive and electronics. But that being said, we are already deployed with a couple of system or small manufacturers that I'm talking about at a scale of 50 team members in one facility. So they are small enough that they are doing these operations. But at the same time, they have already started seeing the potential that, okay, if we don't automate today, maybe tomorrow we won't be able to automate, right? So
Right.
yeah, it's still a small chunk of the business we are doing, but we see a great potential there. Most of our conversations are still towards small companies. So we are still trying to gather as much data as possible, as much understanding about their operations, because they change widely compared to a large enterprise, how they operate, what kind of environment they operate in, what kind of flexibility they might require, right? Like
Yeah.
those are the
Yeah.
challenges once we went into the market. We
Yeah.
started refining our product with it.
Yeah. Okay. Okay. Um, I don't know if you've ever heard of a company called Vention.
Yeah.
You have, yeah. So they had similar thoughts too, right? There's the small, medium enterprises are what make the world go round in reality. And um, their goal is to enable them to build their own automation. So that's an interesting parallel that
Yeah.
I see with your company. So what's it like starting up a robotics company? Is it easy?
No one ever said that. I don't think any robotics founder would be like, yep, it was super simple, no
Yeah,
inconvenience at all. No, it's a difficult thing for
yeah,
sure. I won't downplay it. But that being said, it's very rewarding as well. Because
yeah,
a lot of times, as an engineer, when you build things that move, that has a different feeling altogether than kind of like just on the software aspect or just making kind of like a physical system, right? So this cyber physical system we call robotics, like making these systems give an immense pleasure. But at the same time, since it's cyber physical, we are dealing with hardware, we are dealing with
yeah,
software stack, we are dealing with users, right? Like we are parallelly running three companies that a traditional kind of like entrepreneur would be building on one area.
yeah.
So yeah, it's been challenging. It's been a lot of learning. It's my first company. I never
Okay,
worked in a kind of startup environment before. So
yeah,
learning from some of my mistakes and trying to learn way more from reading books and understanding and talking to different founders. So yeah.
great, great. Well, before we got on the call together, before we hit the record button, you were mentioning you're just on a couple week trip. You were in Europe, so it sounds like you've been able to get into a couple different regions.
Yeah. The best part about simplicity is that you
Yeah,
can sell around the world
yeah,
because you are not relying on kind of like engineers to go in every single area to deploy these robots, and you can ship these platforms and people on the floor can use it, right? So
right,
this has really enabled us to expand our presence. And you're right, like right now we have robots deployed in US, in Mexico, in Germany, Hungary, India, and at the same time we are talking about deploying robots globally, like UK, South Korea, like different countries as well, and
right,
all like not massive deployments. Like even the customers can pick up a robot, couple of robots, three robots, and slowly scale as they want.
right.
So this has really enabled us to expand our presence.
Yeah, good job. So you must be doing something right now. Now, so you talked about it's easy to sell simplicity anywhere in the world. I love that. That's a good slogan. Now, go into some of the specific innovations or some of the things that you guys had to do to, what makes these simple? Because you're working in a pretty unstructured environment. Traditional robotics I've been in since I'm getting older now. So since 2000 that I've been in the field. And one of the big things we always try and do is control the environment with,
Mhm.
the traditional industrial arm robots. So you got to
Yeah.
make sure it's safe. You got to make sure people can't touch, collaborative robots change that game a bit. So now you have people side by side. But the more you control the environment, the easier it is for
Mhm.
implementation. Now, on purpose, you're putting robots out into the, roaming around factory floors. Um, so, what were some of the innovations you guys and some of the features that you guys put in to make this simple?
Yeah, no, that's a very good point. And I think we went back to the drawing board and tried to understand that how people would use these robots. Like it's a mobile
Okay,
robot, right? So the purpose of this platform primarily is to make sure that we can move things. What kind of things? Bins, trolleys, probably some other applications like shelves and all. But in a factory environment, we are moving things constantly from one place to another. Now, how would they do it before using this robot? Mostly someone manually, right? Like, so some person would be moving this trolley and taking it from point A to point B, or from zones, one zone to another zone. Think about it in
Yeah.
this fashion, right? So we went back and we tried to understand that if we have to give a similar robot to do that similar task, how a user would program it. And the most intuitive thing is that, again, that user would want to just show the robot the operation, how to do that operation, and let robot to figure out the accuracy of that operation, right? So let's take an example that we have a robot that can pick up a bin from a conveyor system and go and dispatch it into a production line at another station, right?
Okay.
Now, user can literally just grab a robot, and we understand human haptics. So that was our first patent in this area, which we almost worked on a year for, trying to understand and differentiate what is a human feedback versus what is just like an environment feedback that these robots are seeing.
Does your robot, sorry to interrupt your train of thought, but does your robot provide haptic feedback to the person as well too?
Yeah, so interesting way. So whenever you grab a robot, let's say, and you start pushing it, the drives actuate the system. So you can instantly feel that you are providing just the direction, not the force. So essentially, even if the weight on top of the robot is like 100 kilogram, 200 kilogram, you move the robot, you feel the same intuitive feeling, which is the drives are activated and you're just providing the direction to the robot. But the moment you leave that, like the robot recognizes that, okay, my feedback that I was getting from the user has dropped, so I'll stop. So think of it as, it's not exactly how the force distribution worked, but 10% by the user, 90% by the robot.
Okay. Makes it much more ergonomic, right?
Correct, exactly. Yeah. Anyone pushes it, they know the feeling, like they will instantly get used to it, how the robot is reacting to the feedback. There were some other challenges as well that we had to incorporate, that even if the user is pushing the robot, they don't hit it on the wall. So how we are keeping the lidars and cameras on to make sure it's still safe.
Right.
And the user can't do anything by mistake even to damage the environment or the robot, because that's the most important thing. Like, for simplicity, safety can't be kind of like taken out of context. So safety has to be what is defined, what to make sure that there is no harm done to the environment or to the robot. And then on top of it, the simplicity is built.
Okay, so we're in the environment where we're doing real-time learning with the robot. So you said the person takes grabs a hold of the robot and provides haptic feedback to the robot. It's going to start its motion. Is there like how does the robot know that it's in learning mode? It's based upon a person pushing it? Okay.
Yeah, correct. So there are two ways. That's a very good point. So one is just the overtake. So let's say if the robot was already in autonomous mode or doing a task, you can overtake the robot, and the robot still tracks its position and all that. Hey, yeah, I'm being pushed to this particular location. So consider a scenario where a forklift might be coming in one side of the aisle, and there might be something coming from the other side of the aisle, and the robot and the forklift is stuck, right? What happens in traditional systems, you would have to call an engineer or someone who is trained on the robot to release the brakes on the robot, move the robot somewhere else or at the starting position, and then restart the program, right? In our case, anyone on the floor can just grab the robot, move it out of the place. The robot still recognizes its position. Once the environment is freed, it can go back and do its operation.
Okay. So it has like a self-recovery.
Correct. Yeah. It still recognizes and learns about its position. So it's not losing. As you're moving it, it's not lost in the environment. It's still able to recognize or learn where I've been moved to. But on top of it, we have this interface, which is like web interface, and you can select that, okay, I want to go into the learning mode. And even in the learning mode, you can select whether you want path learning, destination learning, or create a new map altogether, right? So you can teach those or pick up those different learning modes, and the robot, as you move it on a path, the robot will learn that path. If you take it to a destination and say, this is my destination, the robot will learn the destination. So you can teach multiple things using the haptics or the movement physically.
Wow, really cool. Now, would you put yourself in like, is this a human-to-human environment? Is that where you focus, or do you have interactions with other automation that you enable too?
So we do work on kind of incorporating different systems in our platform, but we are starting with kind of just the robot right now. But long-term vision of Peer Robotics is to become more like a platform where SMEs can automate or SMEs can add multiple attachments on top of it,
Okay.
right? So think of it that base robot. On top of it, you can, even today, you can build your own custom attachment. So I said like conveyor top, right? But what size of bin you are moving? Is it like a 600 millimeter height or probably a meter height? You don't know.
Yeah.
You might have to change that. So no matter what kind of attachment the customer wants to build, they can in fact build it on their own. They can get the power directly from the robot. They can get communication directly from the robot, and they can enable, disable using our web interface. Plus the haptics work, no matter what kind of attachment it is. So the robot is
Okay.
trained to make sure that there can be multiple attachments on top of it, and the
Yeah.
haptics would still enable or would still be operational.
Yeah. Okay. Okay. Really interesting. How do you determine between um, like with the haptic feedback between somebody trying to move the robot and or learn and a safety issue?
Yeah. So safety is on no matter what.
Okay.
So safety is by default on whether the user is trying to teach the robot or whether the user is just trying to move the robot. So the robot won't go to or hit to the wall. So we have this 30 centimeter range kind of thing, and we can change that parameter depending on the environment. But the typical idea is that the robot will go as close as 30 centimeter to the wall and it can stop there. So it won't let you smash itself in the wall or any other human, which I realized that every time someone grabs a robot, they try to test it out on other human right away.
Oh yeah, is that a default thing?
Like,
it is.
Oh yeah, 100%. Like once a user is like, oh, it moves on my feedback, and then they're just like taking it towards their colleague or something. So it's good that it always stops.
Yeah, no kidding.
Yeah. On the learning aspect, they do have to select that I'm in the learning mode, so that the robot recognizes that entire, we call it like learning by demonstration, or in manufacturing terms, on the job training. So the robot kind of goes in on the job training and learns about that path sequence or destination. But it has to be specifically selected that I'm in a learning mode.
Right. Well, I think it sounds like you guys are on an interesting track here. I just went to a conference every year. FANUC has FANUC, they do the yellow robotic arms.
Yeah.
You know them well, yeah. So they have their ASI, Authorized System Integrator conference every year. And one of the topics this year is around the collaborative, well, it's been a topic for many years, but they talked about collaborative robots and, how the market is still growing, and it surprised some people, but they're seeing growth in areas where you can't use the robot as collaborative because, so for example, welding. So the minute you put a welding, whether it's tack welding or what have you, the minute you put that on the end of arm of a collaborative robot, you have to protect people from the welding tool. So they can't use it in a collaborative environment. But the key thing was the ease of teach, because of the teaching tools that these collaborative systems have developed to make it easy, right? And that really unlocked a lot of applications, and that's where they continue to see growth, even in environments that the robot wasn't necessarily made for.
So Mike, you brought in a very good point here, because like one thing that we also, as we interact with the customers, and especially a lot of our customers are the customers who are using automation for the first time. This is their first robot that they've deployed, right? So one thing we realized is that this is an area where, as a robotics company, it's our responsibility to educate our end customers as well. That collaborative robot doesn't mean collaborative application. And there is a risk assessment that has to happen on the floor, which need not be complex, but it's about understanding what kind of application is it. And if I'm attaching some solution on top of the robot, how am I enabling that system to operate, right? So take an example where the robot will go and dock to a conveyor system or something with a high precision. So it can go under 10 mm accuracy, go and dock into that system to deliver something. Now, it's very important that the user and the kind of like the operations team understands that how this docking operations happen, and they can't change these docking kind of markers in a random way, because otherwise there might be a human in between, right? So there are certain areas where definitely we have to make sure that we clearly explain that collaborative robot versus collaborative application. Like there are some applications that can be collaborative through and through, but there are
Right.
definitely some application where you would want to make sure that robot doesn't interfere in the operation. Welding is a very good example. If it's in the
Right.
welding environment, it should not operate or should not come in contact with the human.
Yeah. Yeah. So the education that you guys have to walk those first time users through is important.
Yeah.
Yeah. It makes a lot of sense. Makes a lot of sense. Um, so as you guys progress, making your robots simpler, what are some of the like what do you see as the future of human robot interaction? You did mention that you're not where you want to be, so that's good because there's always a new idea once you hit a milestone. Okay, what's the next one, right? What do you see as the future for human robot interaction?
So next phase for us is a lot of work on changing how the operations happen. So I'll go a little bit deeper on how right now, let's say
Okay.
AMRs or autonomous mobile robots work. So currently we give missions to these robots, and the mission is that you go to a location A, which we give exact coordinates that you go to this location. You pick up an object. It can be a human driven, it can be an external system driven. The robot picks up that object, comes to location B. And this is
Okay.
a mission, right? You
Yeah.
give this robot a mission. You can do it using APIs, MES systems, or something. A human
Yeah.
can give it. You can time it. You can create a queue and allocate several missions, but you still give
Yeah.
a mission.
Yeah.
That's not how humans work in manufacturing, right?
Okay.
Most of the time, you tell the human about the operations. Now, what an operation might mean is that, hey, this is my finished good line. Whenever there is a finished good pallet or a trolley that comes up here, you pick this up and you take it to our dispatch area, which is, let's say, defined as 20-meter cross 20 feet area, where you go and stack them up, right?
Yeah.
But whenever a user has to incorporate these robots, they have to change this operation into mission-driven thing. Now, for some
Okay.
applications, it's easy to do that. But for majority of the applications, and especially small companies, it's very difficult to make that transition from operational thinking to mission thinking, right?
Okay.
And I think the future lies where these AMRs or these robots will start learning more about the context of their missions. That what am I
Hmm.
trying to do here? That
Yeah.
am I
Okay.
taking this finished good and this is what a finished trolley or finished pallet looks like? And I'll take it and I go to that dispatch area. And you know what? There might be something already placed at the location I'm trying to store at, but the entire zone is where I can stack. So I'll go and put it
Okay.
into the next available location, right? So these kind of contextual learning is very important. And I think this is where, again, how humans would teach another human that, hey, yeah, you
Yeah.
pick up this finished good from here, this trolley from here, and you take it into that stacking location and just stack
Hmm.
it. You never tell them that this is your exact coordinate. If you missed this exact coordinate, you
Right.
can't stack it, right? So that's what we are working on. And it takes a lot of vision systems again, that how we are able to understand the context of the environment. It takes human inputs as well, that how they define these operations.
Yeah. Really interesting because I'm curious how far you want to simplify that, right? So if you've got a work area and you say, okay, after it's completed this operation, I would like you to go put it in this area over here. And like you said, maybe a 20-meter by 20-meter area. So normally in a robotic system, you would go and teach the drop points, right? And then you would monitor each shelf or each location and say, okay, which one is available, and place it into that
Mhm.
location based upon the top point.
Right.
So how do you make that simpler? Maybe you haven't got it all figured out, or maybe you don't want to release all the details, but that's a big problem, or
Yeah, yeah.
a big problem set to come up with a solution for.
It's a very good point. And I think a lot of these facilities already have figured it out, which are they probably, most of the facilities probably
Okay.
lay down the space with different markers already. So there are these
Yeah.
yellow
Okay.
line markers and
Yeah.
all that they already put in place to give defined zones, let's say, right?
Okay.
Now, can we use that information? We don't know yet. So to be fair, again, we are not there yet. So we are still learning about this environment and how we can operate. But those
Yeah.
are some of these steps that I think we can leverage.
Yeah. Well, that's a great point. People are building infrastructure with
Yeah.
automation in mind.
Yeah.
Well,
So
really interesting. So the times have changed a lot, eh? It's really fascinating. Um, and on similar note, so I've we hear a lot about AI and robotics, and using AI to deal with large sample sets and large decision-making processes. What role does AI play in your systems? Is it an important aspect of the making your robot simpler?
100%. I think simplicity should not come at a cost.
Yeah,
It's like we can probably automate everything and you won't have to intervene anything, but it's going to cost you $1 million. That's
yeah,
probably not the right answer or not the right simplicity that we are talking about.
yeah.
So, to enable the robots to do more, you would have to enable them to learn more from the existing data, right? Like, how
Okay,
can we leverage the existing sensors, existing information to learn more about the environment that previous systems were not able to learn?
yeah,
So AI plays a significant role when it comes to training, to be honest, that this is an area where we are trying to understand, again, coming back to contextual learning, that how do I
okay,
understand the context and focus on the context because rest of the environment might be completely different than what it was trained on, right?
okay,
So in our office environment, if we train a robot to detect a trolley which is filled, we need to make sure that even if it's in a manufacturing environment, in a warehousing environment, in an automotive environment, it can still focus on that particular trolley and make sure that, okay, it is a filled trolley because I've been trained on it, right?
right,
So those kind of applications, it's very important that we train our models correctly to
okay,
ensure that, okay, we can collect the right data, we can train the robot in the right fashion. And all this has to sit on the robot as well, because it has to be edge processed rather than sending the data up on the cloud. Because
right,
again, one of the other philosophy we have is that each robot has to be intelligent enough that human can interact with it and can get results, whether they use one robot, two robot, 10 robot, and SMEs might not have even Wi-Fi, right? So you can't
right,
expect that these robots will be connected to the network.
right. How do you deal with a changing environment? So you brought up a couple things. So you talked about contextual,
Mhm.
the robot operating contextual and looking at trolleys. Does that
Mhm.
help you deal with a changing environment? Because it would be like, let's say the trolley changed location or something around the trolley changed. So in its mapping process, it realized it's hard to localize where it's at, but it sees that
Mhm.
the trolley's there. So okay, I can deal with this because I got to get to that trolley.
A very good point already, because you're right. Like we can set out these landmarks per se. We
Okay,
know that there are certain things that we can
okay,
rely on that are going to stay the same, like pillars, like walls, right?
sure.
But you can change the environment. And this is what our team had been working on recently. And we are releasing this. So we did two releases recently. One was actually with NVIDIA. NVIDIA worked
Okay,
really well on a package called global localization. And we wrote about it along with them a little bit, where now our robots can kind of process the entire map on the GPU level, and we have a complete
hmm.
RTX card in our robot. So
Okay,
we can collect the existing field of view data from the robot, process it on the GPU, and still give under kind of like 20-second localization for the robot. So if the
yeah,
robot gets lost, it can localize itself under 20 seconds directly from that computation.
yeah,
But going even a step above that, there are two ways how we track robots' location, right? Because we don't use any markers in the environment. So there are two ways that we are tracking robots' location. One is the odometry or the wheel data that comes as the robot moves around. We have encoders in the system. We can collect that data. The other one is the LiDAR, like the field of view from the LiDAR that we get,
right,
and we try to compare different environments. Some environments are very different than what we did when we mapped. Some
yeah,
areas are exactly similar what they used to be before because of the walls and all, right?
yeah,
Now we made our system robust enough that when it sees that I go in from a very static environment to a very dynamic environment as part of that
hmm.
map, I'll rely more on my odometry data. And then when I come
Interesting.
back on
Okay,
my dynamic environment or static environment, I'll jump back to my kind of LiDAR data.
and
And the robot
recalibrate.
is correct. And the robot is doing it in real time. So it's not waiting for
Wow.
the user to come back and say that, hey, I'm lost, localize me again. And this took us a long time. Like we probably failed in several facilities, learned from our mistakes and kind of like optimized it. And the team is phenomenal who is building that. I'm no longer an engineer. So all credit goes to our team.
Certainly, I can have an appreciation for that. So, I'm a evening nerd, right? So I took Ross courses. I built my own robot, and my goal was to be able to serve my kids their snack, right? So I tell the robot to go to the kitchen and then just bring it to the couch 1 or couch 2. And then my wife would go and move a chair, and the robot would be off going somewhere. I'm like, "What? That? Don't move the chair!" So certainly it is a challenge, and it's really cool what you guys have done. Okay. All that being said, it's a pretty big technology stack. You guys are taking care of a lot, right? In the name of making things simple. Let's say that I'm a small medium enterprise, and I'm listening to this podcast and you know what, it's time to jump in and try this out. What are some things I should be thinking about as a business for approaching this? What are issues that I'm going to run into, and what are things that I should be thinking about taking care of so that the technology can do its job?
A very good point again here. And I think what I would say is that 2 things come to my mind, which is, first of all, step-by-step progression. Like if it's the first time someone is trying to automate, we highly recommend that rather than jumping deep down into automating the entire operation possible, it's important to break it down into achievable steps so that we are not aiming for the final goal from day one, but we are building up towards that final goal. The other thing is that once we do that breakdown, that, okay, what is that step-by-step automation looks like? What is the lowest hanging fruit that will give us value add today? A lot of times we try to automate operations which are good to have, but not must have. And I think then the scaling becomes an issue, because why would you want these systems if you don't, it's not a necessity, right? So it's very important to go back and see that, is it a necessity today, tomorrow, or day after, right? Like, but slowly how we are going to build up that capacity to take care of that necessity. And then again, breaking it down into even smaller steps. So we always recommend that if it's the first time you're automating, just pick up one robot and see how it works, deploy it, start getting value. Once you start getting value, then scale will come on its own. And then you can start adding different systems, different integrations, but slowly you can grow from that initial step.
Yeah, it was interesting you said about the necessity, because I guess if you get into a situation, you try it out and the novelty wears off, right? And then if it's easier, or the battery dies and you don't need it, then it's easier to let it collect dust in the corner, right? So what are the operations that, whether it's ergonomics or keeping a person safe, that it's better for a robot to manage this dangerous good or this in this messy environment. People are more likely to stay with the technology and grow it.
And I think there are 2 components, right? Like, you make simpler systems that really gives them value, they love using it. That's a reality. It's not like we are not at a stage where we are talking about robots will take the job or anything like that. People on the shop floors love using these systems because in the end, it's making their lives easier. But it has to work. If it doesn't work, then it's easier for them to shut it down and keep it on the side. And not use it ever, right? So that's where we are also very focused that, okay, whatever solutions we do, it's a value add. And we make it simple so people on the shop floor can do it, so that they keep using it. Once they are using it, the top management would have to anyways get more.
Yeah. Absolutely. It sells itself. It's like the puppy dog sale, right? One of my trips that I just went on, I find it really amazing that the different regions of the world, they approach technology differently. So, some regions that are low cost, they rely on that as their advantage. So when you come in, you talk with some companies that, we're into robotics. It gives you quality, that keeps people safe, but there's a price tag associated with it. They say, well, you know what, my labor is cheap, so I'm going to stay that way. Where other low-cost regions, they adopt they've been adopting technology. So, for example, China, they outspend the rest of the world by a huge amount on robotics and manufacturing. Yet, it's known as a low cost area. So, I think approaching this where thinking about the necessity of the situation, the safety of people, and creating a competitive environment for yourself as a company, it goes beyond just replacing people. You don't hear that so much anymore. It's really about the efficiency of people, growing the capacity of your organization. Because the more revenue you get through your organization, the more you're going to secure the jobs for everybody. Yeah.
I mean, I'm from India, right? Like the lowest cost region. Like I'm born and brought up there in that regards, and I can tell you even today that even my dad and my brother and all running different factories, like they would talk about it, that how challenging it is to find people to do that operation. And I will go back and say that no one wants to do that operation.
Yeah.
Like we are at a stage, and China realized it early on, and that's why China is a manufacturing power hub, because they started investing in these technologies because they realized that as the economies will grow, even if you have more people, it's better to use them for different cognitive operations rather than these kind of like entry-level jobs which are not utilizing humans kind of cognition, right?
Yeah.
We have the best AI models running around all over, right? So we got to utilize them. And I think that's a forward thinking. And everyone, like, let's say I'll talk about like people who are working with my dad in their factories. Like when you talk about them, what their kids are doing, they don't want them to work in the factory. They don't want them to do that same operation. They want them to get the right education and go higher up in the ladder, right? Yeah. And we as a society should also want that. Like we as a society should also think about that we have to give these people the chance to kind of operate in the cognitive space. And why not the robot can do up this repetitive and dull and dirty kind of the task that are necessity, but need not be done by humans today. So that's how I look into it. So.
Yeah, and you're saying that even in India, they have trouble finding people to do tasks, and I think in terms of countries, you've overtaken China in terms of population growth, right? But you still have trouble finding people.
But then think about it. Another problem comes is that which geography in India do you live in?
Oh yeah,
right. So let's say, and this is I think this is a very similar problem that other countries, even in US, we have realized that the more isolated the manufacturing is, how would you find people who are willing to come into that location? Because it's not a middle of a big city center. People want to go to the city centers and find jobs there, right? So that's another problem, that if you're operating out of a small village or small area, which a lot of manufacturings are, how would you find the right talent?
Yes. Yeah, and I think the workers are there. They have their family. So just like you said, as their family grows up, they want to provide a better life. So they have to move out to the big city to go to university, so it's hard to retain people. Very cool. Okay, so we talked a little bit before about the US robotics roadmap. So the current release is 2020. There's one coming out in May, so I'm excited to hear what they've got to say. But I compared some notes. And actually, you tipped me off to this because it talked about reference open access test beds, which are, there's sites around, and this is the US robotics roadmap. So they talked about sites in United States or North America, let's say, because I think there was one in Calgary, where they have test beds, and they're open to researchers and developers to try ideas and stuff like that. But there was certain the roadmap talked about challenges of having industry grade test benches to work on and stuff like that. How does your company approach early stage customers who are not sure how robotics fit? Do you have like demo units? How do you engage with customers? How do you do your learning process?
Very good point. So we also have a network of system integrators. And we have started working on creating these showcase centers. So the idea behind these showcase centers is that people can come, experience these robots, program it on their own, if they like, they can look into how they can get the robot for a month or something, just play around with it from that showcase center. And this would allow them to start getting used to the system. Most of the time, we have seen that even if they can see and experience the robot on their own once, the rest of the things are easier to integrate and deploy. The key
Okay.
barrier is that we think about that simplicity. And I can also, like both of us are talking here about simplicity, but someone who hasn't used collaborative manipulator ever in their life, they cannot imagine what are we talking about and how does it operate, right? So it's
Yeah.
important for them to get their hands on it and to work on it. And I think that's what these showcase centers would enable these end customers. But I'll go a step back, like on that roadmap that you mentioned, like
Hmm.
another trend that I'm seeing from that roadmap, and I think that would be included in the new ones that are going to come this year, is these kind of like sites that are for testing and collecting data and all. I think it's going to go beyond physical presence and more on the data layer now. So
Okay.
we have already started seeing there are some startups, some other companies coming along that are creating the data sets that these robots would require in future to train perfectly for these manufacturing environment, for these warehousing environment. And I think these
Okay.
open data sets would become more common, and every company that goes through it would have to kind of start building on that data set. So that's what I'm excited about, that could be
Yeah.
another avenue which could enable future robotics companies to get access to data that currently is very limited. Because if you haven't never deployed it a customer,
Yeah.
like the first deployment was a nightmare. I'm not gonna lie
Yeah.
here. Like the
Yeah.
first
Sure.
deployment
Yeah.
was a nightmare. Like what we expect versus what the environment is. And we have seen it from outside, of course, but once the robot starts working there, then the real challenges or feedback comes in.
Yeah.
And that's what we need to start simulating or start collecting more data upfront from.
Okay. So data sets like, virtual representation of a manufacturing floor. Maybe I don't know if you said each of your robots is self-sufficient, so maybe not shared maps, but the data like that is what you
Yeah.
believe is important to build.
Yeah, like one example is NERF. I don't know if you know about those neural network based kind of like imaging systems, but these
No.
are new systems coming up,
Okay.
which would create the entire photorealistic kind of area map of the environment. Now,
Okay.
granted, it can't be done in a sophisticated facilities and kind of areas where you don't want the data to go out. But at the same time, there might be some spaces that are creating those nerves or other similar kind of data that the robots that have not been developed yet can utilize.
Yeah. Yeah. Interesting. Like a university
Yeah,
environment or something like that. You're not going to go into Lockheed Martin and create a nerf of their site, right? Yeah.
exactly.
Yeah. Yeah. Oh, very fascinating. Very fascinating. Okay, so we covered a lot on robotics, and we we talked about your company and some of the customer challenges. So, last question: what do you like to do in your spare time when it's not robotics?
So I read a lot, or at least
Okay.
trying to read.
Yeah.
And the idea is that from a different perspective, like I like a lot of novels, fiction as well. So that's one area which I try to learn more about, read more about, and definitely a lot of business books as well. It's so
Okay.
fascinating to see how different
Yeah.
entrepreneurs, whether it's like 100 years back or 200 years back, essentially had the same problems still on building a
Yeah.
company. So trying to kind of learn about that process. Then on the other side, jiu-jitsu, I used to do that. I don't know,
Oh
I
yeah.
don't get too much time
Okay.
these days, but love that
Yeah.
sport as well. And yeah, nothing much apart from that. Yeah, love
Okay.
coffee, so probably will make more coffee and drink it for the sake of it. That's it.
It sounds like we could get along pretty well. Give me one book recommendation.
Oh, that's a good one. So I'll go with Crossing the Chasm.
Okay. Yeah.
But I would even say that I recently read the 38 Letters from John D. Rockefeller,
Oh yeah.
and that was
Okay.
also pretty amazing. Yeah.
Okay.
But for an
Okay.
entrepreneur, I would say Crossing the Chasm is pretty good.
Did you set up your bowling alley for your company and did you work through it?
Not yet, not yet. We'll
Not
we'll
yet.
we'll get
Okay.
there soon, but
Yeah,
not
yeah.
yet.
That's something we did here. We went through all
Really?
that exercise. Yeah, absolutely. Yeah,
Okay.
that was a great book.
Nice.
And the Blue Ocean one, of course, is a classic, and that was a good book. We steal a little bit from a lot of different places to try out ideas.
So we recently did this in our team. We gave everyone in our team this book called Extreme Ownership. I don't know if you know, by Jocko
No, I don't
Willink.
know that one. No.
So it's a interesting, like, he's a Navy SEAL officer. I've been following.
I know who he is. Yeah.
Okay. Yeah.
He's
So
pretty intense
extreme
guy.
ownership is pretty good. Yeah. And I got this idea from one of my other mentors, Rach. She's been phenomenally. I always say that she's my American adopted mom. So, but she gave me this idea about this book, and yeah, I think like this is something that we shared with the team. I loved reading it, and I thought it's like also important that in a robotics company, ownership is even more critical, because the one system you work on affects so many other systems that we got to build it as a team, kind of like connected team.
You know what? I'm going to check that one out. So I'm big into podcasts because traffic here in Montreal is a lot of fun. And when I travel, I put on the headphones, and maybe it's as I get older, maybe I have more ADD, but have to concentrate on a book, it's harder. But so I know Jocko because of podcasts.
Yeah.
But then another podcast I got into was he wrote the book. It just slipped my mind. Of course, Never Split the Difference. I have to get the name for you. I'll send you the name afterwards. But it's a little bit about negotiating and stuff like that. So that's one that I discovered through a podcast, and I want to check out. So that's maybe a good one for you to look into. Well, it's a great business book.
No, appreciate it. Thank you, Mike. Yeah, I'll definitely check it out.
Okay. Well, I appreciate your time. It's been a lot of fun chatting. We'll have to do it again in a year or two and see how you're doing, how many more countries you've put under your belt.
Let's do it with the robots too.
Oh, absolutely. That'd be fantastic. Yeah.
No, appreciate the time, Mike. Thanks a lot for having me. It was a pleasure talking.
Yeah, have a great day.
Thank you.
So this concludes the episode of Robotics for All podcast by AV&R. If you don't want to miss another single episode, don't forget to subscribe to our show in your favorite podcast app. Thank you very much, everyone, and we'll talk again soon.